We'll be looking at translation, what it is, and how we can do translations on circles, lines, points, and all that. So I hope you enjoyed this video, and I hope you understand everything well. So let's start. So the easiest way to define translation is when a figure is moved from one location to another while preserving its direction, and it's also in the same distance. So let me do this with an example. For example, if you have a line that's facing this way, we will preserve its direction, which is this way, northeast, and then we preserve its distance or its length, and then we're gonna move it to here. So this is what translation looks like. So translation preserves the distance and also the direction of the object. Now let's look at points. When we translate a point from this coordinate to this coordinate right here, we can draw a vector that will be formed between them. Let's call this P and this P prime. So this will form a vector. So there is this thing called translation vector, which will be written in the form of A and B. So the amount of distance that this point traveled to come here is going to be the distance that's going to be added on the original coordinate. For example, if P is x comma y, then P prime will be x plus A and y plus B. So this particular translation vector not only changed the distance, but also gave us a new coordinate. So we can algebraically show this. So this translation vector moved this particular point P to P prime by adding these coordinates onto it. So obviously it preserves the direction, it is in the same distance. So this is how we call it translation. Now let's do this one tricky question that most exams have. So guys, what the question basically says is the image of a point 1, 2 under translation T is 2, 4. What is the image of the point -2, 3 under the same translation? So here we're asked to find one thing, but in order to find the translation of this particular vector, we need to find the translation T and then find the image of this point through that translation. So the first thing that we need to do is what we're given. So we are given a particular point. It's translated by some translation vector A comma B, and then it gives us 2, 4. So remember the formula, okay? Don't forget this formula. P equals xy. So when it's translated to A comma B, then it is x plus A, y plus B. Okay, never forget this. If you know this formula, is pretty easy. So to find out, we need to find out what A is. So let's plug in the numbers. So obviously, 1 plus some number is going to be this. So we're going to do this in the form of a equation. So 1 plus A equals to 2. And then the same thing for B. So 2 plus B is going to be 4. So now we just need to solve for the variables. So our final answer won't be this, but we're pretty close. So our translation vector would be 1, 2. Then now let's find the image of -2, 3. This is pretty easy. -2 plus 1, 3 plus 2, which will be P prime is going to be -2 plus 1 is -1, 5. So this is going to be our final answer. Now let's do some line translation. This is going to be a bit harder, more difficult, but it's more or less the same concept. So let us recall the basic equation of a line, which is ax plus by plus c equals 0. When this is translated through the translation vector a comma b, so this is going to be our formula for L prime, or the image of L. Now let's try this equation out with a problem. So we're given the following equation. We are given one of those tricky problems that first ask us to find the translation vector, then we're gonna calculate the image of the line. So let me write down the question and then we can do it together. Okie dokie, so we are given if a translation t takes the point -2, 3 to point 1, 2, then what is the image of the line L 3x minus y plus 4 equals 0? So the first thing that we obviously need to do is find the translation vector. We can do this in a very easy way like I showed you before. So I'm gonna give you guys a few minutes to do this question, so feel free to pause the video and do this question. Okay, so let's do it together. First, point -2, 3 to point 1, 2. So the image is 1, 2. So -2 plus some number will give us 1. And then 3 plus some number will give us 2. So all we need to do is solve for A. When we solve for A will be 3 and B will be -1. So our translation vector will be 3 minus 1. Now let's apply the formula from earlier that I showed you. This. So all we need to do is just plug in the numbers and then move along. So let's plug in the numbers. So L prime will be equal to A. So in this case, this 3 will be A. So A, and then A would be 3, so, and then we open brackets, and then we put in x minus our translation vector, which is 3. Then plus, and then on the outside, we're going to put B. So in this case, B is -1. So the coefficient of our y coordinate, which is -1, and then y minus our translation vector, which is -1, plus 4 equals 0. Now let's solve every number. Let's distribute everything. 3x minus 9 minus y, and then here it's going to be plus pretty much. So minus y minus 1 plus 4 equals 0. Now let's solve for x. We're not going to solve, but we're going to simplify everything. So 3x minus y, and then minus 9 minus 1 minus plus 4. It's going to be -6. So -6 is equal to 0. So don't forget to put a prime here. But as you can see, the coefficients of our x and y components don't change. The only thing that changes is the constant. So what this shows is that translation does actually preserve the exact distance and also the direction of our original line. So just like other plane transformations, when we translate a circle, the only thing that changes is the coordinates of the center, but the radius is kept intact. So for example, if we have this circle and we have its coordinates right here and the radius r, so the only thing that changes when we translate this vector is going to be its center. So let me show you guys. So as you can see, the only thing that changed are their coordinates. So it went from 2, 3 to -2, -3. So now let's do an example problem. So in most cases, what we're given is the following. So if you're given the translation vector, which is, let's say, -2, 2, its center, which is 0, 0, and we need to find the image. So we're also given the equation of the circle, x squared plus y squared equals 4. So our general formula, so if our center is at the original right here, then all we need to do is just plug in the new coordinates and then simplify everything. So what we're going to do here is this is our final circle equation. So please be on the lookout for, there is one more rotation video left and there are 2 more reflection videos left. So after I post those 3 videos, there are going to be a general review exercise for everything thing we talked about: transformation of planes, reflection, translation, and rotation. So we will be doing that in the next few days, so be on the lookout for that.